Are we ready? Awesome. So I just want to point out what I want to kind of help you guys out with today. I think we can actually take off both of the teaching stuff today because I don't think either of them is too long. And then that means you guys have, so let me backtrack. I have bookmarked this week to finish up the internals in class. If you guys aren't done by the end of the week, I'm going to be moving on with the teaching, but we can set a different deadline. You guys can work on it at home still. So I want to talk to you guys and see how you guys feel on Friday on when we want, or maybe not Friday, Thursday, to see how you guys are feeling with the deadlines. So I want to make sure it fits in with everything else that you're doing. For the microbes people, let me just find your stuff. So, internal assessment. I just want to pull up the marking criteria and point out some other places that I noticed you guys struggled with. And I also want to pull up my notes so I know what I want you guys to cover. So, like I said previously, I noticed a lot of you guys were having issues with this first merit requirement here, which is the linkage of the how the factor. We talked in our previous lesson how this one is a common one that you guys struggled with, which is talking about how the factor influences the life process of the bacteria or the virus or things like that. When we looked at the notes from the other day, they are online now, so don't stress. Here they are. We were looking at this one, how it affects life processes. So we looked at a lot of graph data and things like that because I wanted you guys to explain the mechanism how it was affecting it. So the big thing there is thinking about chemical reactions. A lot of you guys chose temperature, so being mindful of how temperature affects rate of reaction because that's then going to be the component that's affecting your bacteria or your virus or your fungus. The other thing that you could be writing about is enzymes because when we're talking about bacteria and fungus, they have enzymes. The viruses, they might have a few enzymes, but clearly not as many because they need to hijack the cell. So just kind of keep that in mind. That's what we were talking about. So I do need to see an explanation to what is happening, what the factor is doing to the life process of the pathogen. Are we okay with that so far? So a lot of you guys identified it, but you didn't explain why. When you guys go to explain why, it's not going to be specific to your pathogen. It's going to be more general information. Does that make sense? Hopefully? Okay, I see some head nodding. Good. All right, so that one I saw a lot of you guys were struggling with. And the other thing I wanted to point out is just talk for the final point about the data. And explain the data. I just want to point out as another option. And then the other thing I want to talk about is this excellence criteria here. And I will probably just do a quick little write-up just to show you what I mean when we're thinking about cancer cells and how that has life processes, things like that. So I think there is 2 more bits of paper that we haven't had a talk about yet. So I'm hoping all this kind of puts into conceptualizes some of the things that we're missing. And I just got more paper. Clumsy. Alrighty. So, get the document camera going. There we go. All right. So this was basically day 1 of our clarifications. We were looking at viruses in a little bit more depth because a lot of you guys picked viruses, but we're struggling with that. So just be mindful that was what we covered there. We also looked a little bit at some viral data. So this was flu data and looking at the infection rates increasing during the wintertime. Being mindful that you have to be careful when you're talking about temperature because you're thinking about temperature of the human body, not temperature of the surroundings, but you could talk about how temperature of the surroundings might influence how people behave and things spread. So do kind of keep that in mind. So we talked about that one. We also, like I said, talked about rate of reactions and enzymes and things like that. And we also looked at this piece of data here too. All right, there are 2 more little slips of paper I just want to point out to you guys. I don't know if I want to glue it down and write any notes. Yes, I do want to glue it down and write notes. I've decided that. The other thing I want you guys to think about when you guys are looking at data is I'm okay if you guys choose data that's not specific to your pathogen, but instead is a general bit of data that shows something about viruses or bacteria or fungus. So let me show you what I mean by that. by these last two bits of data. I'm just looking for my glue stick. Here we are. Okay, just trying to think which one I want to do first. Probably this one. If you guys are wondering, that one. It's the next one I'm going to talk about. I'm going to write the first note down. So when you guys are providing data, it'd be great if it's specific to your pathogen, but you can expand your scope if you are struggling to find data for your particular pathogen to just general bacteria or general viruses or general fungus. All right, so I'll write that down as a note so you guys are aware of that. Ideally, you want to find data on your pathogen. But if you're struggling to find that data, or if you don't understand the data you find, or you don't understand the data, you can use data that's more general. And I'll give you guys some examples of some more general data. So I should actually make this sideways so that way when I write, I don't have to move it. All right, so for example, you could use data like this. Now, the data that we see over here is talking about enzyme activity at different temperatures. So even though this is not related to a particular pathogen, and in fact, it's not even related to viruses, bacteria, or fungus, you can use data like this because this data explains what's happening with your enzymes at different temperatures. So it is okay for you to use data like this. They're not specific on the assessment what type of data you use. It just needs to be data that you can integrate in. So this data here will prove a life process, and that is pathogens are sensitive to temperature, and this is the reason why it's sensitive to temperature. Are you okay with that so far? You could also, like I said, include general data. So I have put some data here that is a bacteria growth curve. Ooh, I need more glue. I did not glue that well. So this here is data specifically for bacteria. Now, it's not specific to a type of bacteria, but you can use this again if you are doing a bacteria write-up. Now, in this case, what we see here is it's a bacteria growth curve. So we see that this here is a measurement of the amount of bacteria that we have, and this is as time passes. So initially, we have a lag time and very low populations of bacteria, and then they grow exponentially upwards. Because it's showing growth, this is showing reproduction. And then we see that it gets stationary and kind of levels out. And then we see a dropping of the bacteria numbers. So, why does the bacteria number drop? It's growing, it's reproducing, it's doubling, and then it stagnates, and then it starts to decrease and die. Why do they start dying? Any ideas? What do they need to survive? What do bacteria need to survive? Food. What happens when you have a lot of bacteria? Is there more or less food? Less. So they're eating up and they're using their food, so that's why they're suddenly dying off. Running out of food. AKA our nutrients. So again, that's something else that you can consider. So if you are struggling to find data for your particular bacteria, just find like bacteria data or viral data. Does that make sense to people? So if you're struggling to find data, you can go generic. All right, this is generic. This stuff here is all generic stuff, which still can improve a life process. All right, I've got a second one here, which again is a general one that I thought was useful to see. Glue this guy down. So the last one. I'm just gonna make a note. These are examples of general data. So those are acceptable to use. So what we see here in this case, let me grab a different color, talking about a different graph. You see how there's time, and we see also on this one, the CFU, it's a measurement on the amount of bacteria there. We have three different bits of data. We have the control, which is the dots. We have the bacteriostatic, which I need to double check what that is. And then we have the bactericidal, which is, whenever you hear the word homicidal or suicidal, what does that mean? It kills it. So if I see bactericidal, what does that do? Kills bacteria. I'm guessing bacteriostatic must be something that limits bacterial reproduction. Would be my guess. So limits bacteria growth. It doesn't kill it. This one kills it. All right, so as time goes on, they're growing, and then you see with the control, it's very important to include a control so that way you know where the baseline is. It continues to grow, and then it plateaus up here. All right, the circles that are not colored in the white circles, we see that it grows, but it doesn't grow to the same amount. So if we were trying to make a conclusion, we see that the bacteriostatic decreases the maximum amount of bacteria growth, so it inhibits bacteria growth. And then the bactericide actually kills them, so that's why it's dropping down to 0. All right, now when we are comparing these two against each other, these would both be, depending on what bactericide you use or bacteriostatic you use, it could be an abiotic or it could be a biotic factor. Most likely it's going to be an abiotic factor because it's going to be a drug or something like that, or a chemical. Abiotic factor. Let's explain that right. It's generally a chemical. And that's obviously interfering with growth. So you talked about abiotic and biotic factors. This is an example of an abiotic one. Most likely is what they're using because it's going to be some sort of chemical. So like taking an antibiotic, like taking a drug. All right, are we okay with that so far? So you can use general data. It doesn't need to be specific to your pathogen. It would be great if it is, but I'm also very mindful that it might be hard to find that data. Make sure whatever data you use, you understand it. Don't just stick something in there for the sake of sticking something in there because part of the merit requirement is explaining it, okay? Are we good? All right, move it? No, that's okay. Let's move this down because I feel like I'm really high up. Do you need help? Bactericidal, I'm sorry, my handwriting's really bad sometimes. Most likely a abiotic factor, like a chemical. Any luck? You're got a device? Yeah. All right, I can tell you what your options are. All right, while you guys are writing that down, I'm just gonna talk to our new student and you guys can get that last bit of note down.